Hello everyone, welcome to read our commentary published in iMetaOmics, titled Climate Change Amplifies Global Mycotoxin Exposure, Emerging Risks and Sustainable Solutions. This work was completed in collaboration with multiple institutions, including the Agro-Environmental Protection Institute of the Ministry of Agriculture and Rural Affairs and the Oil Crops Research Institute of the Chinese Academy of Agricultural Sciences. We will now briefly introduce the core contents of this study. Mycotoxins are toxic metabolites from fungi like Aspergillus and Fusarium, commonly contaminating cereals and threatening food safety and public health. Over the past century, rising CO2 has warmed the planet. Climate change alters mycotoxin contamination through multiple mechanisms. Warming drives toxigenic fungi poleward at 2.7 km/year. Elevated CO2 modifies plant physiology and fungal toxin production, and precipitation shifts. Droughts, floods, humidity, shape regional risks. These interacting factors make the situation increasingly complex. Over 400 mycotoxins have been identified to date. They enter the human body via the food chain through inhalation, dermal contact, and ingestion of contaminated products. Extensive evidence confirms their carcinogenic, mutagenic, reprotoxic, and immunotoxic effects. Infants and young children face particularly high exposure risks. A UK biomonitoring study detected deoxynivalenol in 95.6% of children's urine samples, with over one-third exceeding the tolerable daily intake. Moreover, certain mycotoxins can cross the placental and blood-brain barriers, posing risks to fetuses and pregnant women. Mycotoxin contamination rates are rising with climate change. Our analysis shows deoxynivalenol exceeds 75% in major cereals globally, with fumonisins and zearalenone surpassing 70%. Followed, we projected future risks under different climate scenarios. Under the high-emission RCP 8.5 scenario, contamination risk across major regions is projected to rise significantly by mid-century, South Asia by over 100%, with East Asia, South America, Oceania, Eastern Europe, and North America all showing clear upward trends. Low-income countries face even greater challenges. FAO data show their cereal mycotoxin exceedance rate rose from 14% to 19% between 2018 and 2022. Weak infrastructure, limited monitoring, and insufficient expertise leave these countries most vulnerable to climate-driven contamination. To address these challenges, we propose 4 priority actions. First, build a global predictive surveillance network integrating climate, crop, and fungal models into a multi-scale forecasting framework for timely, region-specific risk warnings. Second, deploy field-ready biosensors. Antibody-based and DNA receptor-based devices offer rapid, in-situ, and accurate detection, enabling real-time early warning. Third, promote climate-resilient agriculture and accelerate breeding of resistant crop varieties to suppress fungal proliferation and toxin production at the source. Fourth, establish a multi-stakeholder governance mechanism that strengthens monitoring infrastructure, technical capacity, and public awareness in developing countries. In summary, since the 1960s, rising temperatures, CO2, and changing precipitation have been driving mycotoxin contamination to expand into higher latitudes. Global surveys show contamination rates in major cereals have exceeded 70%, threatening food safety and public health. Low-income countries, with weak infrastructure, limited capacity, and low awareness, face the greatest challenges. The 4 actions we propose, predictive surveillance, biosensors, resilient agriculture, and targeted governance, form a systematic framework to mitigate climate-driven risks and safeguard global food security and public health.